Okay, Wildcats. Today we're looking at Monday, April 16th, Graphing Polynomials, Part 1. And that's going to be on page 72. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, Graphing Polynomials on page 72. Name by degree. So when it's x to the power of 1, it's linear. And there are the examples of the graph. When it's x to the power of 2, it's quadratic, and there are examples of the graph. When it's x cubed, it's cubic, and those are examples of the graph. When it's x to the fourth power, it's quartic, and those are examples of the graph. And then when it's x to the power of 5, it's quintic. And there's not an example of a graph, but if you graph an x to the power of 5th, you'll see the curves. There's just a lot of curves, and that's why we don't have an example. All right. The number of turns is 1 less than the degree. The x-intercepts, also known as the zeros or roots, is when f of x is equal to 0. To find them, you solve when f of x equals a 0. Now, the solving methods to find the zeros are method 1, factor, method 2, quadratic formula, method 3, synthetic division. Zeros can have multiplicity. Now, here, if it only crosses once, it's multiplicity of 1. If it touches and turns, it's multiplicity of 2. If it goes through the point in a cubic curve, it's multiplicity of 3. And behavior, write using infinity notation with respect to the arrows. And we'll explain that as we do the examples. So if you would, update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, find the following information for each polynomial and then sketch a graph. The degree name is the highest exponent degree. So in this case, it's 3, so the degree name is cubic. The leading coefficient is the number in front of the highest exponent degree. So in this case, it's 2. The number of terms is 1 less than the degree. So since the degree is 3, the number of terms is 2. All right, it's an odd degree. Now, the y-intercept is the last number in the equation without the x. So since here, there is the number after that, would we consider that as plus 0? So our y-intercept is 0. Now, to identify the zeros, we have 3 methods. And we're going to start with method 1, factoring. So here, we see that we can factor out an x and a 2. So that's the greatest common factor. So let's do that first. So we factor out a 2x, which leaves x, that's a bill, x squared plus 2x minus 15. And we're going to set that equal to 0. Now, to see if you factor correctly, we just remultiply. So 2x times x squared is 2x cubed. 2x times 2x is 4x squared. And 2x times negative 15 is negative 30x. All right, so now we're going to factor this. Now, to do that, we need to find all the factors of negative 15. So we know negative 1 times 15 Negative 2 doesn't work. Negative 3 times 5. Negative 4 doesn't work. Negative 5 times 3. So we're looking for the combination that makes a positive 2. So this is this combination. So our factors are x minus 3, x plus 5. So now we set each of those factors equal to 0. So 2x equal to 0, x minus 3 equal to 0, x plus 5 equal to 0. So here we divide both sides by 2, so 0 divided by 2 is 0, so x equals 0. So our 0 is 0, 0, which is also our y-intercept. Okay, so here we add 3 to both sides, so x equals 3, so our 0 is 3, 0. Now, when you notate it, because we're just sketching, okay, it's not exact, we're just sketching. Okay, so instead of putting the 3, 0, we're just going to put 3. I'll put 0 there. Okay, here we subtract 5 from both sides, so x equals negative 5. So 0 is negative 5, 0. We're just going to put a negative 5. Okay, so to understand the sketch, we go back to our notes. So here, this is cubic, so we're looking at this shape. Now, when the leading coefficient is positive, our curve is this. When our leading coefficient is negative, our curve is here. And I can actually go ahead and put that note for that goes apply for those. So the leading coefficient is positive. These are the shapes of your curve. Okay. When the leading coefficient is negative, this is the shape of your curves. And basically it tells us the direction. So in this case, we're going up. Here we're going down. So that's our curve. All right. So we come up, but it's going to be slightly different because we have turns. So we have 2 turns. So we go up, we turn once, and we turn twice. Now, the shape is slightly different because we don't just have x cubed, but we have an x squared and an x in the equation, okay? All right, so our end behavior. So as x approaches negative infinity, so we're going this direction. So as we go this direction on the x, the y's, or the f of x, are approaching negative infinity. Basically, in simple terms, as we go left, the graph goes down. Now, as we go right, which is in positive infinity, it's going up, so it's approaching positive infinity. All right, so now let's look at example 2. All right, so the degree name is, the highest degree is 4, so it's quartic. The leading coefficient is 1. Number of terms is 1 less than degree, so that's 3. It's an even. Now the y-intercept. Now we have to do something to define the intercept first. We need to move everything to the left side. So we're going to add 36 to both sides. So now our equation is 1x to the 4th minus 13x squared plus 36 equals 0. So our y-intercept is the last number without an x. So in this case, it's 36. So our y-intercept is 0, 36. So we're sketching, so we're just going to, we know 36 is above the x-axis, so we're just going to put 36 there. All right, so identify the zeros. So method one is factor, so we're going to factor. Now, here, this is x to the fourth, but we have three terms. So we're going to factor it with two parentheses. Set that equal to 0. Now we know x squared times x squared gives us x to the fourth power. Now we need to find out the combinations to make 36. Now, because the last number is positive and the middle number is negative, both numbers have to be negative. So negative 1 times negative 36, negative 2 times negative 18, negative 3 times negative 12, negative 4 times, I believe, negative, let's see, 9. So we're looking for the combination that makes negative 13. This makes negative 13. So there's our factors. So x squared minus 4, x squared minus 9. Now, this one is unique in that these are difference of squares. So we can factor this some more. So this becomes x minus 2, x plus 2. And this becomes x minus 3, x plus 3 equals 0. So now we set each of those equal to 0. So x minus 2 equal to 0, x plus 2 equal to 0, x minus 3 equal to 0, x plus 3 equal to 0. So we add 2 to both sides, so x equals 2. So our x-intercept is 2, 0. So we have a 2 right here. Now we subtract 2 from both sides, so x equals negative 2. So our x-intercept is negative 2, 0. Okay, now we add 3 to both sides, so x equals 3. So our x-intercept is 3, 0. And then we subtract 3 from both sides, so x equals negative 3. So our x-intercept is negative 3, 0. All right, so we look at the degree is positive, so we look here. So we know that it's going up on the left and going up on the right. But when we graph it, we're going to go this direction. Okay, but this is the general shape of the graph. Okay, so we're here. Now we know we have three terms. So here's one turn. We have to come up here. There's your second turn. And then there's your third turn. Okay, so end behavior. So as we go left, that's negative infinity. So as x approaches negative infinity, we're going left. F of x is going up, so that's not equals. F of x is approaching positive infinity. So now as we go right, we're approaching positive infinity. The graph is going up, so f of x is approaching positive infinity. All right, so go ahead and finish that up. All right, now let's take a look at example 3. All right, so the degree name would be quartic. The leading coefficient in this case is negative 1. And the number of turns is 1 less than degree, so that's 3. It's even. The y-intercept in this case is 0, so 0, 0. All right, so identify the zero. So method 1 is, and that's really what we're focusing on it, part 1, is the factoring, okay? So we're going to factor. Now, see, looks like the greatest common factor is a negative 1x squared. So we're going to factor out negative 1x squared. And you always, whenever you can, if there's a negative 1.
Good morning, teachers. This morning and today we will not have bells, so please be mindful of the time and release students from your class as according to the bell schedule. If you have any questions, please send me an email.
No bells. Woo! Thank you, Ms. Rogers. All right. So here we're going to factor out that. So that becomes x squared. And then that becomes negative 2x and then minus 8. And the way you check to see if you factor correctly is remultiply. So negative 1x squared times x squared is negative 1x to the fourth. Negative 1x squared times negative 2x is a positive 2x to the third power. And negative 1x squared times negative 8 is a positive 8x squared. All right, so this is as factored. Now we need to factor this. All right. So we know x and x make x squared. Now we need to find all the combinations to make negative 8. Since the last number is negative and the middle number is negative, one number has to be negative, one has to be positive. So negative 1 times positive 8, negative 2 times 4, negative 3 doesn't work, negative 4 times 2. So we're looking for the combination that makes negative 2. That's this. So it's x minus 4, x plus 2. So now we set this equal to 0. So negative 1x squared equal to 0. X minus 4 equal to 0. X plus 2 equal to 0. So here we divide negative 1 by both sides. So you get x squared equal to 0. But then you take the square root of both sides, plus or minus. So you get x equals plus or minus 0. Okay? So that means technically you have two zeros. So you have x equals 0 multiplicity of 2. And your point is 0, 0. Now, that's relevant because here in our notes, when you have multiplicity of 2, it touches and turns. Okay? All right. So now here we add 4 to both sides. So x equals 4. So our point is 4, 0. Okay, and here we subtract 2 from both sides. So x equals negative 2. So our point is negative 2, 0. Okay? Now, our leading coefficient is negative. So it's going down. Okay, so this is the general direction of our graph. Okay? So we're here. We go up. Now it's going to turn 3 times. So we go up. There's one turn. It touches and turns. There's 2 turns. And it turns back down. So there's 3 turns. All right. So our end behavior. So as x approaches negative infinity, we're going left. It's going down. So f of x approaches negative infinity. Now as x is going to the right, that's positive infinity. F x is going down, so that's f of x is approaching negative infinity. All right, so at this point, you have 2 paths. If you understood all the examples, start working on an assignment. If not, come to class and you can work in the group that's going over the assignment together. Okay, so with that, have a wonderful Wildcat day.